Hello everyone, my name is Nayara and I'm a 4G PhD student at Virginia Tech. Today, I will present my PhD project, evaluating augmented reality heads-up display effects on driver performance and distraction. Distracted driving, especially because of the use of secondary in-vehicle displays like cell phones, is a deadly epidemic around the world. Just in the US, it's estimated that distraction kills 8 people a day and generates a cost of $22 billion a year. So the big question is, how can we help to reduce distraction potential when using secondary in-vehicle displays in driving? A promising solution to this problem is to use augmented reality heads-up display in vehicles. AR HUDs display information in front of the driver's forward field of view that now don't have to physically look away from the road to get the information needed. However, AR in vehicles will be a fundamentally new driving experience in which drivers must still attend to both the road and the information provided by the display. So if not well designed, AR HUDs can be the perfect environment for both dangerous and distract interfaces. We cannot assume that AR HUDs will help to resolve the distraction problem just because you display information in front of the driver. We need to understand the effects of AR interface on driver performance to inform the design of good interfaces. But first, what is a good AR interface in driving? To answer this question, we need to measure the effects of AR on human behavior when driving. Therefore, the question becomes, what are the best methods to assess AR HUDs on driver performance? Traditional HCI methods for evaluating AR interfaces usually focus on time on task and accuracy and errors. However, in driving, AR is no longer the primary task. AR only supports the primary task of driving. So knowing performance on AR tasks is important, but it's only a small part of the bigger picture. We need evaluation methods that are rich enough to capture all the effects of AR HUD interfaces on human behavior. Especially when we talk about AR and distraction in driving, we need to actually understand how drivers allocate visual attention using the technology. This becomes even more complicated because there is no visual separation between the driving and the AR task demands. Because visual allocation of attention and distraction are linked, the focus of my PhD work is on methods to measure visual attention when using AR HUDs. The current standard for evaluating visual allocation in any type of in-vehicle displays is the eye glance measurement method. This method was developed at a time when displays were located in the center console of the vehicle. This is basically a pass and fail test based on the idea that a 2-second glance away from the road or towards the display is the amount of time that can turn deadly to a driver. However, recent work performed in my lab revealed that when compared to traditional in-vehicle displays, HUDs resulted in longer glance towards the display, but no decrement in driving performance. In fact, drivers showed better vehicle control when using AR HUDs. Therefore, when we use the current standard to assess visual attention, the assumptions that we make about HUDs are inconsistent. Without new methods, we are left to base user interface design and assessment on the current understanding of traditional in-vehicle information systems. Visual location in these systems is fundamentally different from AR HUDs, and so the current methods are more likely to fail any type of HUD interface. That being said, the major goal of my PhD is to reassess and update methods for assessing visual distractions that account for AR HUD. To accomplish my goal, I will evaluate glance allocation and visual capabilities of drivers with AR HUDs and apply this knowledge to inform new methods of assessment that account for both inattentional blindness and cognitive tunneling. My PhD work is divided into 3 main research areas with 4 major phases. Because we know that AR HUDs afford glances longer than 2 seconds, the goal of the first phase of my work was to establish thresholds for AR glance duration. Here, we wanted to understand how long can a driver and how long will a driver safely glance at an AR HUD. In this phase, we established thresholds for the longest possible safe glance, and we developed a set of ecologically valid and generic psychophysical AR HUD tasks of comparable visual demands. For this phase, we already collected user study data, and we are in the phase of analyzing and publishing our results. The thresholds and generic psychophysical AR tasks that were developed in this phase will be used in phase 2, 3, and 4. In phase 2, the major goal is to develop methods to assess drivers' ability to detect events occurring in the central field of view, like a lead car brake light. In phase 3, the major goal is to develop methods to assess drivers' ability to detect events occurring in the peripheral field of view, like an approach pedestrian. Finally, on phase 4, we plan to conduct an actual on-road user study at the Virginia Smart Road to validate our methods developed on phase 2 and phase 3. Because my work is still in its infancy, I'm looking for feedback and discussion upon phase 2, 3, and 4. I welcome feedback on my research questions, experimental design, experimental tasks, and metrics. Also, I'm interested in discussing challenges and confounding factors for performing outdoor AR user studies. Last but not least, as a first-year PhD student, I also welcome mentorship on career as a college professor performing AR human factors research. In summary, as we advance the state of human-machine interface technologies, we also need to advance the process by which they are designed, built, and especially evaluated. We need better measurement methods for AR HUDs that account for distraction, because if we cannot properly measure an interface, we cannot improve it. Thank you for your attention. I will take any questions.